NASA's Parker Solar Probe is a mission to explore the Sun. How can it do that? Why won't the spacecraft melt? Excellent questions. You can't face off with the Sun without packing the right gear. This is why Solar Probe is equipped with a white shield that reflects heat off the front and keeps things cool in the back.
The heat shield is made out of a couple of different materials. One is carbon-carbon, which is a lot like the graphite epoxy you might see in your golf clubs or your tennis racket, but it's just been superheated. The inside is a carbon foam, which is just another form of carbon and is actually about 97% air. It's a very lightweight way of making a very strong structure.
Nobody likes a needy explorer. Solar Probe can take care of itself, thank you very much. And that's because it has autonomy software that will keep its instruments safe and cool behind the heat shield.
We're too far away to joystick it into place, so it basically has to always be sensing whether or not the heat shield is in the right position and correct itself if it isn't. There are these things called solar limb sensors that are just poking out at the very edge of the shadow, and if those get illuminated, the spacecraft knows, oh, I'm going the wrong direction, and can actually right itself.
It's important to stay hydrated in the Sun, even for a spacecraft. Solar Probe circulates water to keep the solar cells from overheating. It stays cool and keeps power.
So basically water flows behind the solar rays and into the radiators, and so the water warms up when it's behind the solar cells and then cools down up at the radiators, and so that heat transfer is happening a lot like the veins in your body.
Yes, you read right. Heat is not the same as temperature. Temperature is a measurement, but heat is energy transfer. This matters because Solar Probe will be visiting the Sun's outer layer, the corona. Like all stars, the Sun is made of plasma. How tightly packed that plasma is depends on the layer. While the Sun's corona has a very high temperature, the plasma particles are fairly spread out. So even though the temperature in the corona is 2 to 3 million degrees Fahrenheit, the heat around the spacecraft is manageable.
The corona and where we're going is actually not that dense at all. There are only a couple particles. And so when we think about it, those are very hot, but we're not touching a lot of them. It's the kind of like when you put your hand into an oven, and the oven might be at 400 or 500 degrees Fahrenheit, but your hand isn't at 400 or 500 degrees Fahrenheit.
Thanks to its design and destination, this cool, confident spacecraft is all set to explore. We can just sit back and chill as Parker's Solar Probe takes the heat.